What if we could simulate nature down to every atom with perfect accuracy? What if one chip could unlock the power of 1,000,000 qubits? This isn't science fiction, it's Microsoft's Majorana 1, and it might just redefine the future of computing. Today's supercomputers are powerful, but even they fail at simulating nature's most basic building blocks. They choke on the behavior of just 30 electrons. Why? Because classical bits, 0s and 1s, aren't enough. Quantum bits or qubits can exist in multiple states at once, enabling exponential power in computation. But there's a problem. Qubits are fragile, they're noisy, error-prone, and hard to control. Most quantum machines today can barely hold a few hundred reliable qubits. They're slow, bulky, and not scalable. Just like we needed the transistor revolution for modern computing, we need a new quantum architecture. Enter the Majorana particle. In 1937, a brilliant Italian physicist named Ettore Majorana proposed a radical idea, a particle that is its own antiparticle. This mysterious particle, now called the Majorana, defied the rules of physics, existing as both matter and antimatter at once. For decades, scientists searched for evidence, hoping to glimpse a particle that could unlock new realms of quantum science. But the Majorana was elusive. Its signals were faint, easily lost in the noise of the quantum world. Why does it matter? A particle that is its own antiparticle could revolutionize quantum computing, making qubits more stable and less prone to error. For years, the Majorana remained a theory, an elegant solution waiting to be proven. Then, after decades of failed attempts, Microsoft's quantum team achieved the impossible. They not only observed the Majorana particle, they learned to control it, harnessing its unique properties for quantum technology. This breakthrough marks a turning point, a new era where quantum computers can finally become powerful, reliable, and scalable. Using the Majorana, Microsoft created a new state of matter, and with it, a material called the topoconductor. Think, a semiconductor and superconductor combined. It's the foundation of a new architecture, the topological quantum computer. And the result? A topological qubit, small, fast, stable, and resistant to noise. Finally, a qubit that can scale. This is Majorana 1, Microsoft's first quantum chip based on this architecture. Every atom is placed with purpose. It doesn't use electrons to compute, it uses Majoranas. This tiny chip can hold over 1,000,000 qubits. It's fast, efficient, and controllable. Everything traditional qubits are not. Majorana 1 works as a quantum accelerator. It partners with classical systems to solve complex problems, then synthesizes the results for real-world use. The power of this system? It can simulate materials as accurately as a real-life experiment. Imagine designing drugs, energy systems, and materials without a single failed trial. With 1,000,000 qubits, we can discover new medicines in days, not decades, create perfect battery chemistry on the first try, engineer new materials before they're ever built, supercharge AI models with unprecedented depth. We're not just speeding up computing, we're redefining the limits of what's possible. We've lived through the Stone Age, the Iron Age, the Silicon Age. Now we stand at the edge of a new era, the Quantum Age. And Majorana 1 isn't the end, it's just the beginning. If you're excited about the quantum future, hit like, subscribe, and drop your questions below, because the quantum race has begun, and you're now a part of it. Introducing Majorana 1, the world's first quantum chip built on a revolutionary topological core. This breakthrough chip uses a new material, the topoconductor, combining the best of semiconductors and superconductors. Like the invention of the transistor sparked the digital age, Majorana 1 launches the era of scalable, reliable quantum computing. With unprecedented stability and power, it's ready to solve industrial-scale problems faster than ever imagined. The future of technology is here. Majorana 1 is leading the quantum revolution. What makes Majorana 1 so extraordinary? It all starts with a new state of matter, the topoconductor. Microsoft's team engineered this material by layering indium arsenide and aluminum at the atomic level. This unique structure lets Majorana particles appear at the edges, particles that are their own antiparticles. When encoded in the topoconductor, these particles create topological qubits, naturally shielded from noise and errors. The result? Qubits that are fast, robust, and scalable, ready for real-world quantum computing. By mastering the topoconductor and Majorana magic, Microsoft has changed the very building blocks of computation, ushering in a new era of technology. Imagine a world where a 1,000,000-qubit quantum computer transforms the impossible into the everyday. In environmental science, quantum simulations could break down stubborn microplastics polluting our oceans. Molecules once thought indestructible, now dismantled with atomic precision. In materials science, quantum computers could invent self-healing materials, bridges and airplane wings that repair themselves like living tissue. Quantum-powered AI could design perfect catalysts and new molecules in days, not decades, revolutionizing medicine, energy, and manufacturing. With Azure Quantum, these breakthroughs scale instantly, connecting researchers and industries across the globe through the cloud. The result? Industries are transformed, product design becomes flawless, supply chains optimize in real time, and new solutions emerge for humanity's biggest challenges. The million-qubit era isn't just about faster computation, it's about reimagining what's possible and building a better future for everyone. Quantum computing is no longer confined to the lab, it's rapidly becoming the engine driving real-world solutions to humanity's toughest problems. Let's explore how quantum breakthroughs are being translated into industry-shaping applications, with a special focus on Indonesia's unique challenges and opportunities. Take plastic pollution, for example. Today, microplastics choke our oceans and rivers, and existing technologies can't fully break them down. Quantum computers, with millions of qubits, can model and design novel catalyst molecules capable of converting stubborn plastics into useful or harmless materials. In Indonesia, where plastic waste threatens marine ecosystems and livelihoods, this could mean a cleaner environment and new economic opportunities. Infrastructure is another frontier. By analyzing how materials degrade at the atomic level, quantum simulations pave the way for self-healing materials. Imagine bridges, roads, or airplane wings that repair themselves in Indonesia's challenging tropical climate, extending their lifespan and ensuring safety. Quantum computing is also set to revolutionize healthcare and agriculture. With the ability to simulate complex enzyme behaviors in minutes, quantum-powered AI could accelerate the discovery of new medicines and sustainable biofertilizers. For Indonesia's vibrant agricultural sector and rich biodiversity, this means more tailored treatments, healthier crops, and a reduced reliance on harmful chemicals. What's more, platforms like Microsoft's Azure Quantum are making these innovations accessible. By merging quantum computing, AI, and high-performance cloud technology, researchers and businesses can solve problems intuitively sometimes by simply describing what they need in plain language. This synergy empowers Indonesia's growing tech ecosystem, enabling local talent to tackle global challenges and drive digital transformation. The era of practical quantum applications is just beginning, as breakthroughs like the Majorana one-chip move from research labs to real-world deployment. Industries across Indonesia and the world stand on the brink of a quantum leap forward. The future isn't just about faster computation, it's about harnessing quantum power to build a smarter, more sustainable world for all. Building a million-qubit quantum computer demands engineering at the atomic scale. Every atom in the materials stack is placed with precision, creating flawless layers for quantum operations. Digital control systems synchronize millions of qubits, orchestrating signals with picosecond accuracy. Imagine a symphony where every note must be perfect, otherwise the quantum music collapses into noise. Custom cryogenic electronics keep the quantum world stable, operating near absolute zero. Breakthroughs in fabrication, error correction, and interconnects are paving the way to scalable, fault-tolerant quantum machines. Teams of physicists, engineers, and software developers, often in partnership with DARPA, are uniting disciplines to solve unprecedented challenges. Each milestone, from new qubit materials to advanced control chips, brings us closer to utility-scale quantum computing. The Majorana one chip, small enough to fit in your palm, is now being installed in data centers around the world. This is the invisible foundation beneath the quantum leap, a story of creativity, precision, and persistence. Together, we are engineering the quantum future, one breakthrough at a time. The journey to scale quantum computing is just beginning. Every breakthrough brings us closer to solving real-world problems once thought impossible. Microsoft envisions a future where quantum power is accessible, reliable, and transformative for everyone, revolutionizing medicine, energy, security, and more. This ongoing journey unites researchers, engineers, and dreamers across the globe, all pushing the boundaries of what's possible. Imagine the possibilities, because the future of quantum computing is being written now. Will you be part of the revolution? As we look ahead, quantum computing stands poised to transform our world, tackling challenges once thought impossible. But with this power comes responsibility. As quantum breakthroughs accelerate, we must ask, how do we use this technology wisely? Privacy, security, and fairness will define the quantum era. The choices we make today will shape the world of tomorrow. That's why global collaboration is essential. Scientists, engineers, policymakers, and communities are coming together, sharing knowledge and setting standards for responsible innovation. This is not a journey for the few, but a movement for the many. The future of quantum computing belongs to all of us. Whether you're a student, a professional, or simply curious, there are countless ways to get involved through online courses, open research, and vibrant quantum communities. Ask questions, share ideas, and help shape the next chapter of technology. The quantum future needs your voice. The story of quantum computing is still unfolding. What role will you play?